Hello. Hi. Welcome to this DBMS experiment number 3 video. This video I am recording here for your reference purpose. As per your previous two videos, this is the another video for the solving of your DBMS as an academic syllabus part of experiment. Experiment number 3. So here I will explain about this, what I am going to do here, right? So the thing is, if you gone through about the basics of a MySQL, it's the question you can easily solve within half an hour. It will not take more than that. But yes, in this question, some basic understanding of a clauses is required because when you will solve this question, when I was solving, I found that some in-depth advanced queries will be applicable, right? So guys, whatever I'm going to explain here, please follow the instructions. You can be able to solve this problem very easily, okay? And the practice is needed, okay? Though it is basic one only, basic in the sense from the whatever we have done in the classroom based on that only, okay? So you observe here this experiment number 3, the need for maintaining digital academic records is growing rapidly. Educational institutions such as schools, colleges, and universities have started storing students' details such as name, age, mark, and enrolled courses in a structured database. Guys, I will tell here whatever this experiment is given, you know very well what this is in fact, okay? Why? Because you people are day to day, you are seeing these things as a part of academic being a student, right? So this will help you to solve the even your I can say if you are getting the such kind of questions in your SEE exam, there also it will help you out, right? So what they are telling, this helps in tracking the academic performance, course enrollment, and individual student progress efficiently, right? So design a student performance management system. This is one of the tasks they have given. Design a student performance management system database that stores the details of students, their enrolled courses, and the marks they obtained using the following relation schema. Relational schema they given means tables they have given student table, course table, marks table, right? In students table, the attributes or columns they have given like SID means student ID, S name, age, gender, course. Now observe here, course. Okay. So course table they have given, course ID, course, okay, course name and instructor, marks for student ID and for the particular course ID, what marks he is getting. So observe here, this is the called as your integrity, referential integrity between the tables. Until you are not aware which student is having in which course, you can't enter the marks. It's very common, okay? So you think about the as a problem statement, what they are defining in the given experiment. So this is how you have to read the questions. While reading the questions only, you have to get the idea what they are asking. Okay. Again, they are defining the constraint. What they are defining the constraint? SID, SID. You see here SID in given student table as a primary key and the foreign key in the marks table, right? So student and marks table you can connect with the help of this. Okay. Course ID. So course ID will get in the course table, and that would be the primary key in the course table and the foreign key in the marks table. So course table will get connect with in through I mean table marks, right? So linking you are doing with the help of this. So data integrity you have maintained, right? So guys, whenever I'm explaining these things, I'm always highlighting the DBMS characteristics properties which we have studied with respect to the constraint and the structure which is already I have explained in the relational schema, right? Now these are the questions. Okay, 15 questions are there. Maybe 15 only. Yeah, 15 only, right? So create the student course and marks table. First, you have to create the table. You itself, you have to create the table, right? Then you have to insert the some sample records into that. So when you will create the tables, after that some sample records, some 5 rows you can insert in that. Okay. Then update age of the student who are having student ID 3. Very easy question. Rename the column name. Okay. Again, rename you can perform. Delete from the student table as SID. I mean, student row 5. Maybe he failed or dropped out or something. You want to delete this record. So this likewise, you have a 15 questions. Uh, so I'm taking you on the MySQL directly. I have solved already. Again, I will run in front of you those questions. What your task is, since these questions are easy only, you have to watch the video as a reference. You have to note down the queries. Okay, you have to type in your system, and then you have to get the output. You have to match your output with my output. If it is matching, then you have to write in your record. Again, I'm here informing you all, while writing in record, please do not make any mistake. Nice way you write. Top of your file, whatever record file is there, experiment you mention, whatever conditions they given, like experiment, this till here they have given. Okay, you write down. Okay, one by one, write down this queries, and down to that write the query, whatever query is there. If you are getting output, beside to that you write down the I can say your outputs. Similar way you have to do. Okay. If anything important you are feeling, you can put comments also. I am always putting the comments because whenever you see the things, you can easily recall the things. Okay, practice needed. Okay, let me share the MySQL so that we'll start with a direct practical part. I will try to conclude fast. Okay, I hope this screen is visible to you. So first I will create the one database for the student performance management system, right? So I have given command called as create database, and I have given database name as student performance DB. First I need to create this. Observe here a green tick mark came. So it is created. Database is created. I need to refresh my schema. Then I will get the particular student performance DB. I need to select this schema, or else you can run this also. Both way you can select the particular database. Now you can see here all the things are here. Okay. So I have divided this complete operation into three parts. Data definition language, data manipulation language. Okay. So DDL part, creating of a table. You saw now one question they asked the create the tables. So this I will do first. This is your first query. So you must follow the I mean constraint which is they have defined. So while doing the table creation, you must follow these things, okay, which they have listed out. Okay. So first, you have a three tables: course, student, and marks table. So first I will create the course table. In that I have taken course ID, course name, and instructor. These things given already in your syllabus. You have to take course ID as integer, and you have to define it as a primary key. This all mentioned in your syllabus. Okay, blindly you can do this all. Course name, they have given varchar, and you have taken course name should not be null, right? You have created given constraint, and instructor you have given as a varchar. Here name you can give. Okay. Similarly, student table I am going to create. So student ID, you can say USN. Oh. So what the pattern mentioned in that order only, I will do that, right? After that, again, SID I have taken as a primary key. I have declared the constraint. Okay. Next part is a student name, again, age, gender, and courses. These things I have taken. Now, you see here, total. Now you come to the marks table. Now here you have to be very careful. SID integer. You know this SID and this SID. This SID is primary key, and if you are creating the same, I mean you this SID will act as a foreign key. Okay, so that you can connect the your student table with the marks table, right? After that, course ID, you see course ID again, course ID in the course table. So it is a primary key. So this will connect the your I can say course, I mean marks table with the course table, right? So this is what marks table. Okay, marks table, which we'll use to store the marks. And you have taken as a composite key. Guys, we be careful what is composite key. A student can only have one score per course. Understood now? Go through. If you are getting any doubt related to composite key, primary key, please go through. I have already explained in the classroom. Recall the things. And you see here, I have used on delete cascade. On delete cascade. Those who have attended my class, they are understanding what privilege I am giving by this. Okay. So foreign key, I mean, you are connecting the your course table and the student table with the marks table by writing this referential integrity lines. Okay, foreign key for this SID, referencing to the student table SID, and on delete cascading means you are deleting some data, automatically it will allow to delete. Okay, foreign key course ID referencing to the course table, course ID. On delete cascade means if any student is not there in the classroom, I mean he left, you can be able to delete. And similarly their courses also you can be able to delete, right? So that constraint we have applied here. Phase 2, insert of the data. So question number 2 given, some sample record you have to store in the given particular table. So course table I have, so 1 2 3 4 rows I have taken, inserted. Okay, so with respect to these attributes, columns, I am inserting these data. So first let me create the table. So I will create the course table, then I will create the student table, then I will create the marks table, then I will insert the values in the course table first. You see here, I have inserted. You can cross check by running the query like select, okay, select all from course. Okay, this you have to write and run it. You will get the table. Okay, so this data came into table. Similar way, I will create the different tables. See, in the student table, I'm going to insert these values. Okay, so you can refresh it. You will get here everything. Okay, what you have done. In student table, we have these columns, SID, name, age, and gender, and courses. These I'm going to insert it. Okay, I'm going to insert in the student table. So let me run it. Okay, inserted. You want to check it. No. So simply, I will perform the query. Students. Okay, now student, sorry. Then I will run it. You will get the data inside the table. Same data. Now similarly, I will run the some values in the marks table. You see what are the columns: SID, course ID, and marks, and some 1 2 3 4. I mean, you see here 10 rows I'm going to insert with respect to that subject wise. Okay, so let me insert it. Okay, so let me insert it. So this is how you are inserting, and you can cross verify whether it is going inside the table or not. So it will be there, right? Marks. After that, let me run it. Yeah, marks data came into the marks table. Now third phase is, now I will perform DML operation, like some questions they have given, update and delete basis. So they are telling update the age of the student who are having student ID 3. So let's say earlier we have inserted for the student 3 age was 19. Now I want to update it 20. Okay, so update student table, set age equals to 20. Earlier it was 19, where student ID 3. Run it, it will work. You want to cross check? You check it. Where you will check it? In the student table. Okay. See, earlier it was 19. Now it became 20. You see here. ID Chetan Yadav, now 20, right? So this is how you can update the table. Similar way, they are telling rename the column as name to the student name. So earlier it was, you see here, where is the student name? Column name as name they have given, right? Now I want to make it like student name that is given in your question. Okay. So this is the fourth question. So alter table, schema you are going to change. So you have to use alter command. Alter table, student, change column, as name, student, name, change, alter table, student, change column, as name, student name, varchar not null, right? So now if I will refresh it, you can observe here, now it became a student name, right? So this is how you can change this also. Okay. Next, we have a question, delete the student whose student ID 5. I mean, you think about some student was there. And why I have given permission in the referential integrity on delete cascade. Guys, please be careful about these things, okay? So that's why it will get delete, okay? Ishan Verma, a student ID 5 was there. And since he left the college or something happened, now you want to delete his data from the student table, you can delete. So if you want to check cross verify, when I executed student table, where it is, you see here, fifth row was Ishan Verma 22, and this is the his this one values we have given. Now let me delete it. So how you will delete? Delete from student where is student ID is 5, where is one class which is used to filter the data, right? So you see successfully done. Now let me run it. Let me check it whether it is there or not. So you observe here only 4 SID, fifth SID gone. So I hope you are getting this. Then I need to perform some retrieval operation with advanced aggregate functions. So count the number of students from the student table, right? So select count SID as, I mean, count operation. Apply count operation. This will give the number of rows, okay, from the student table. So you see here total number of 4 since we have deleted one row, okay, permanently. Find the maximum marks obtained in any course. So again, max aggregate function, pass the marks, okay? And from the marks table, you will get the maximum marks, 95.50. You can cross verify is min marks. Suppose we inserted in where we inserted in marks table. So you see here minimum marks 85, 78, 92, 65. So 60 marks is minimum. So that data we want to fetch. So we will use select mean, pass the marks from the marks table. You see marks, okay, marks column you are passing as minimum marks and from marks table. You see here 60.5. That should not come now. That should not come now by any course what we have feeded. Oh, sorry. The third column 65.5. Oh, yeah, yeah. Why it's I mean, you see here, 75, this one is more. And if you count this, this one may be less or equal only, but in the order, this is coming first. That's why you are getting the 65.5, right? So it is correct. Okay. So this is how you will run it and get it, the output. Retrieval the average marks grouped by each courses. Okay, okay. This question is good. You need to understand. So you see here you have to use join here, right? And that too with average, I mean that aggregate functions. And I can say retrieval the mark, average marks. And here you have to be very careful. Average marks grouped by each courses. First you see the courses. You see the courses. Let me show the course. See, course database, data structure, web development, Python. These are the courses. Course ID, these are. Okay. Now, see the marks table. Okay. No, sorry. I was running mistakenly. Course ID wise, marks given, right? So we need two tables to run that program. Okay. Retrieval of, I can say, retrieval of the average marks grouped by each course. Okay. So marks you will get from the marks table, course name you will get from the course table. So two tables you need to join. So course name will come from the uh, yeah, uh, from the course table, right? And marks will come from the marks table, right? So you want to show course name from the course table and the marks table, marks from the marks table, right? As a average marks because you have passed the column particularly from the average. So you are joining this, you have joined through inner join, then group by this particular, you want to show display the your average marks with respect to course name, and that should get ordered in descending order through the average marks. Those who are having higher marks, that will come first. Okay, so let me run it. You can calculate it. See, the web development 91.7 and Python 8.89. database 80 point something, data structure 74. Okay, so let's say here it is coming more larger, so we can make it like short, I mean average marks. Okay, how you will do that? So to do that, where you have counted average marks, you have to go there. For example, here, so here only you give the round. Okay, you give the round, and uh, round only two decimal part only you want to calculate. Now you run it. Now you run it, you will get the some round figure, you see. So this is how you can perform the round figure also. Okay. Okay, I hope you are understanding, because this we have discussed. We have lot of practice on these topics. That's why I'm not focusing much. You are aware about this. Display the total number of student enrolled in each courses. Okay, again count the number of students which is enrolled, which they got enrolled in the each courses, right? So again, custom course name you are counting from the course table, and the student data you will get from the I mean. Uh, Sorry, what is display the total number of students enrolled in the each courses. So from the course table you can map like the particular course name, count the number of student from the marks table, which is mapping to the course number of courses. And here you have to use left join to include the course with zero enrollment student, if any. If any student who have not enrolled in any courses, that also information you will get from the left table. Left table means your first table you have taken as a course table, right? Then marks table, and you will come to know, and you just go through. Okay, this all we have done, so this count you will get, right? 11th question, list the student names and marks in descending order of marks. Okay, list the student name and marks in the descending order. So student name, their marks, and their course name from the marks table, student table, and course table. So two join operation you have to perform, two inner join you have to perform. Okay, nested join you have done, and then you have applied referential integrity, and then you are counting in the descending order. It is given straightforward. It is, we have discussed multiple time, and you are getting this information: student name, marks, and the course. Okay, so guys, this is all very important. I'm going a bit fast because we have done in the classroom. Those who are struggling, if you are getting any doubt, please do let me know. I will clarify all the doubts. It's online, and I'm expecting that you are well aware about these basic concepts. That's why I'm moving forward fast. And this kind of question you may get in your practical exam. So do practice properly. Retrieve the sum of marks is scored by student in each course. Okay. So what is the answer? Retrieve the sum of marks is scored by student in each course. Now you just think how many tables you require. So marks table will come into picture and courses table will come into picture. Okay. So what I will do here, uh, so course name from the course table, and I will do the all the sum of marks from the marks table as a total marks is scored from the marks table. Then I will join these two tables. Already referential integrity we have performed, so this is not an issue. Then you are grouping by course name and arranging with the help of order by uh, mm, okay. So let me run it. So you are getting, okay, course name and their total marks. Okay, so you are getting here now. The question number 13, they have asked, display the minimum and maximum. And one more thing I will say, here you are using the clauses, okay, group by, order by. I mean, what the functionality I have defined in the clause, you know very well. So please be mindful here, right? Display the minimum and maximum marks from each course, 13 number question. So minimum and maximum, this is easy for you. Okay, I'm not going to explore it. Okay, this is the very easy question. So this you go through. Okay, you will get minimum and maximum marks, two columns for each courses, right? So basically join, group by, these concepts you have used, right? With along with aggregate functions. Find the average age of a student. Very easy question. Go through. Okay. So total average of the, I can say, if someone will ask what would be the average age of the entire class, So I will pass the age age column in the aggregate function average, it will count. Okay. And last question. List all the courses in alphabetical order along with the number of enrolled students. List all the courses in alphabetical order along with the number of enrolled student. How many tables are required? Tell me, guys. Here you need course table and marks table, right? And course name, and you're counting the number of student, right? From the course table. And again, and their enrolled student you will get from the marks table, right? From the marks table. So this is what you have taken, then group by and ordered by, and clauses you have been used. So left join, group by, this is all you have used. Okay. So you have seen that what we have done in the entire this practical. Okay, let me run it so that you can come to know what output we have got. So this is enrolled student course wise. Okay, this is my output. So guys, all the 15 questions I have solved from the beginning to ending. Okay. So if I will summarize this all, so this all the experiment depending on the student performance management system, there you have to create one database. Okay, there you have to create the database. You have to define the schema with the help of DDL operations, and that we have done. Then you have to define the DML operation. There you have done lot of insert operations. You have performed a specific update and rename and delete operations. Then you have performed some, I can say, data query operations. So this operation you have performed, and in that you have used like 10 complex analytical queries you have performed, I can say. It's in some aggregate function count max mean you are using with the clauses like group by and order by, like. Okay. And data ordering you're doing through the order by. So this all we have done easy only, but your understanding is required, and join we have used. Okay. So this is all about the third experiment. Please write your record properly. Any doubt, please let me know. I'm uploading it on YouTube. Okay, and after that I will share it, and you just follow the this guideline and instruction and write it. I mean, first you execute this entire script, understand it, and get the output, match your output with my output, everything is fine, then you write it properly. So this is how we are completing the third experiment, guys. Okay, after that two more I think, no, three another experiments are there. So fourth, fifth, and sixth we will do in next week, right? Sixth we'll do after our fifth module. Once you will complete the I can say your NoSQL part, then we'll do the sixth. Fourth and fifth we'll do, right? After transactions. Okay, guys. Please do it, okay, properly. Any doubt, please let me ask, and do prepare properly. Okay, I am expecting that all you guys will perform in the practical properly. Okay, best of luck. Thank you.